Aircraft ignition systems. Okay, which is easier to do? Build a sandcastle or kick it down? Which can you do quicker? Kick it down. Okay. So how do we induce the high voltage for our spark? We collapse the magnetic field over what part of the circuit? The secondary coil, right. How do we produce the spark? We collapse a magnetic field over the secondary windings. Then all we got to do is use a distributor to point it in the right direction, and we'll get ignition. Okay, good to know. I want to know that soon. Right, add more turns to the secondary winding. So which has more turns, primary or the secondary? The secondary, right. That's to produce higher voltage. What part in the magneto is used to stop the current faster? What part in the primary circuit is used to stop that current faster? The cam opens the breaker points, but what causes what do we use to speed up? The capacitor, thank you. The capacitor protects the breaker points, but it also speeds up the slowdown. It accelerates the collapse. It makes a faster collapse, a faster, sharper slowdown in the current. Why? Because it gets rid of the spark that was going to happen at the breaker points. Okay. A weaker intermittent spark and arcing at the points. Right. No spark at the spark plug. It's possible. It's possible that you'd get no spark at the spark plug, but it's more probable that if you spun that magneto fast enough, you would still be able to get a spark, but it wouldn't be dependable. Voltage being too high at the spark plugs, that's like saying you got too much money in your bank account. It's not really a problem for us. Anybody have too much money in their bank account? No. Voltage in your spark plug being too high? Not a problem. Hope that was a misclick. Ooh, probably the most important question on this test. And not well known. Bonus points for people who got it right. Where did that come from? The internet? No. Came before the internet. Hitchhiker's Guide to the Galaxy. Absolutely. One of the best books ever written. If you haven't read it, you should read it. Really? I haven't watched the movie. I can't. Because I like the books too much. And I'm pretty sure there's no replacement for displacement. That's true. Except now we got turbochargers, and we actually sort of did replace displacement with turbochargers. Or gas turbines. I'm afraid to watch the movie because the books were so good. I think I'd be really disappointed. I don't know how you can do that. Maybe if they had enough budget now, they could do it. Yeah. Feeding your 427 big block is kind of the problem. Yep, 2 for a single magneto and 4 for a double magneto. Yeah, our magnetos have a 2-pole magnet, and if you look in the FAA, you'll see pictures of a 4-pole magnet, and that's in a double magneto. The magnetic circuit. Right. I actually had you name the parts of the primary circuit. The magnets that look like plus signs. Yeah, that's a 4-pole magnet. Let me pull up. Our 4-pole magnet looks like north, south, north, south. Is that what you're looking at, Aiden? And the magnetic lines of flux go like that. Yeah, that's a 4-pole magnet. And then in our magneto, of course, we've got a simple north-south built into the input shaft. Oh, where'd my Kahoot go? Kahoot, where'd you go? There it is. All right. They're parts of the magnetic circuit. 3 circuits. What are the 3 circuits in our magneto? Three circuits in our magneto. What are they? Primary, secondary, and magnetic. Primary electrical, secondary electrical, and the magnetic. And which one of those is external on a low tension magneto? The secondary electrical, right. We do that so that we're pumping. So the distributor now, instead of having to control 20,000 volts, only controls 200 volts. And 200 volts is pretty tame stuff. It does what we tell it to do. You can probably stick your fingers in the socket and most of the time survive with 200 volts. Don't try it. This hasn't been recorded. But 200 volts is fairly survivable, and it's pretty tame. It'll go where you tell it. 20,000 volts, that's a different animal. It does what it wants. This is kind of my way of thinking. I'll probably go back and explain it, because my guess is I won't get a strong answer in here. Ha, even worse than I suspected. All right. Let's go here. Here's my high tension magneto. Okay, I've got a growing and shrinking magnetic field right here, right? I'm going to make 200 volts here, and it would come in a sine wave that would look like this. I'm going to have, plus 100, minus 100 volts and time. That makes sense? I've got a changing magnetic field because of my rotating magnet, and I'm going to get a couple hundred volts in there. I've got 10 times as many windings in my secondary. What kind of voltage will I get there? Well, I'll get a sine wave that looks exactly the same, but this will be plus 2,000 and minus 2,000. Right? Everybody with me? I got 10 times as many windings. I've got a growing and shrinking magnetic field, and that's what I get if I don't have my breaker points opening, as in if my ignition switch is closed and my current just flows and does its thing. I'm going to be running on, where's that resultant curve? I would be running on a resultant curve that didn't do the collapse. It just did this. Putting the spike in there, hang on, maybe I should try and line this up. Let's try and line this up. My voltage, I put my voltage down here in my secondary coil. Whenever there's not much change, I'm going to have very low voltage. Whenever there's a lot of change, I'm going to have a voltage spike. So consider how steep the curve is there. If you look at, let's get rid of all this stuff here, go back to a pointer. Right here, we're not steep at all, right? Right here, we're fairly steep, but look what happens here. See how steep that is? That's an absolute cliff. And then here, it's fairly flat. And then this is an absolute cliff going the other way. Wherever you've got this cliff, a really sharp change, we get a very high voltage. Now, this cliff doesn't last for very long. It's only like 1 degree long, right? But it's incredibly steep. That's what gives us our high voltage. So if we didn't have breaker points in the circuit, we're going to end up with that. We basically do that. Oops, I got to get back to my eraser. That's what closing my points does, or closing my ignition switch does. It effectively gets rid of my breaker points, because now the electrons have got a choice of, instead of going through here, they will simply go through there, and I still get a completed circuit. And then instead of getting a super high voltage, I get a medium voltage, and 2000 volts is not enough to jump my gap. Okay. I don't know how well I explained that. Can I get some feedback? Was that okay? Helpful? Not helpful? Okay. Awesome. People were listening in parallel with the breaker points. Good to know. High voltage alternating current. Remember, because sometimes you got the north pole of the magnet whizzing by and you get your current going one way. Sometimes you got the south pole going the other way, and then you get the current going the other way. High voltage alternating current. Oh, I didn't talk about this too much yet. I'll have to do a drawing. So go ahead and make your best guess. And not many people guessed right. Okay, so why? Let's look at this. I've got my system here, and I'm going to have an alternating current. Get rid of all that, not important. Okay, so I'm going to get myself a positive polarity spark here. I've got an alternating current. What's the next one going to be? Negative. Then the next one will be positive. Then the next one will be negative. Actually, let's think about this as north pole went by, south pole went by. So I got a north pole, then I got a south pole, then I got a north pole, then a south pole, then a north pole. Oh, look at this, south pole. And then I'm back to north pole. And this is going to just keep on going in circles like that forever. And that would give me a plus, a negative, a plus, a negative, a plus, a negative. Does that make sense? Even number of cylinders, I get. Now, what problem would that cause for the engineers? Sparks actually jump in a certain direction because it's electrons jumping. If my electrons are always jumping this way, they're going to eat a little pit out of my spark plug, and they're going to put a little mountain on the other side. In a car has got a DC system, a battery system, and the engineers know that the spark will always jump this way. And they can design the spark plug, to work with a particular polarity of spark. They know that the engine is always the ground. They know that the spark is always going to jump from power to ground. They know what they're going to do. And they can handle that. In an airplane, when the manufacturer makes a spark plug, they have no idea if it's going to be we'll call it a positive polarity spark plug or a negative polarity spark plug. So this is going to cause a wear issue with our spark plugs. And this is kind of delving into the next lecture. But what we do is every 100 hours or every annual, when we take our spark plugs out, we take the spark plug from cylinder 1. If this was cylinder 1, oops, let's change my color. 1, 6, 3, 2, 5, 4. Where's the updated schedule? I don't know that we did a complete updated schedule. Oh, is it posted? On D2L. Ah, there we go. Mr. Cliff did it. Good. Mostly it affects a couple of Thursdays got swapped for Fridays. So you're going to be on campus basically every Tuesday and every Friday would be my guess without double checking it. Because we had every Tuesday on campus and then alternating Thursdays and Fridays. So now it's going to be Tuesdays and Fridays. Or maybe the last week hasn't. I don't know. Take a look at the schedule. Mr. Clove will have that. Okay, so back to what I was saying. Every 100 hours, we're going to take the spark plug out of number 1 and put it into cylinder 6. And the one from 6 and put it into 3, 3 and put it into 2, 2 into 5, and 5 into 4. Does that make sense? That rotates it's like rotating the tires on your car. You take the front tires off and you put them back onto the back. And you take the back tires off and you put them onto the front. And then the fact that your tires on the front of your car wear out faster than the tires at the back of your car gets evened out, because the tires in the front of your car typically, on an odd-numbered radial engine, we don't need to worry about that. Good question. On an odd-numbered radial engine, every spark will automatically alternate. And so they don't have that problem. On a radial engine, they've got more of a problem of the top spark plugs being nice and clean and the bottom cylinders getting really dirty. So they will rotate top to bottom, I believe. But I haven't worked on radial engines, so that is kind of speaking as a guess. But their problem is not going to have anything to do with polarity. I'm told actually some of the companies put expensive spark plugs on the back and cheap spark plugs on the front, and they just don't rotate the ones on the back because they're really hard to reach. All right, back to the Kahoot. Okay, so most everybody got this wrong. Hopefully now everyone will get it right. This is important to know. And half the class got it wrong. Don't know what to say. I think I actually said it's a test question. So people still missed it, like half the class. So let's go back, take a look at the diagram. Must have missed something. Let's take a look here. Is this magneto in a run position or an off position? Then if I spun this magneto, would it make a spark right now? Is this in a run or off position, the way it's drawn? Off. This is in the run position. And here's why. These breaker points are key to this system, right? They trigger the spark. When they open, we collapse this. So we stop this circuit, we collapse the magnetic field, and we induce a spark. What happens when I open these breaker points if this switch is closed? I've got electrons running in a circle here, right? What happens when I open these breaker points if this switch is closed? The electrons come up. I'll draw it in a different color. They come up here. They get to this point. They see that my breaker points are closed, so they just go this way. And I still have a completed circuit. Braden, does that make sense? And you're with half the class here. Opening the switch. Okay, opening a switch. Does an open switch conduct electricity or not? No. Okay, so how can opening the switch ground anything? You're right, the switch grounds the coils. But open doesn't ground it. Open is the off position. Closing the switch grounds the coils. You see that? Closing this switch connects this end of the switch, of the coil, to ground. Open disconnects it. Does that make sense now, Braden? And thank you for being the only person to kind of step in and admit that you didn't understand. This switch here connects to ground, and it connects to ground when it's in the closed position. We got you with me now? An open switch interrupts the spark because the current can or can't flow. An open switch, is this switch open or closed? Right. So that switch is open. Does the spark happen when those points open or when they close? Right. So the current can't flow. So what we need to do is take our current that can flow when these breaker points are closed and make it so that it can't flow because the breaker points are open. But if I close this switch, the current can flow anyway because it doesn't need the breaker points anymore. It's like, what if I put 2 doors into the classroom? And unfortunately, we need to switch because open doors and closed doors is the opposite way. But if I put 2 doors into the classroom and I opened one of them, as long as one door is one path exists, people will be able to leave the room. People will be able to run around in a circle, okay? Interrupting the spark. Interrupting the spark means preventing the spark. Is that a misunderstanding? Interrupting a spark means preventing a spark. What was my question wording on the Kahoot? No, that's not the one that I want. Let's go back to there and come to here. And there we go. Okay. Interrupting meant preventing. Well, just be careful if you're memorizing the word, just the sound of the words, because interrupting the switch, the spark, means preventing the spark. And the closed position, does that provide a path to ground or interrupt the path to ground? because I do word the questions differently to make sure that you're understanding it, and then sometimes students get confused on the wording. Preventing the spark. Do I want to provide a path to ground or interrupt the path to ground? I provide a path to ground to interrupt the spark. Yeah. And here's another one where doing that drawing before you get into the test is really helpful, because you can see on this drawing, as long as you understand this drawing, this is in the run position. This is a running magneto. This switch is open. If I do that, I have provided an alternate path to ground. Sorry, that's really hard to read in green, but I've provided an alternate path to ground. All right. And it's a relatively simple question, but it does seem to get a lot of people. All right, back to the Kahoot. All right, remember my Rube Goldberg machine? What's the magnet induce? The purpose of the magnet is to induce an electric current in the primary winding. Thank you. Yeah, induction is when we change, whenever I say induce, we're changing magnetism to electricity or electricity to magnetism. Or electricity to electricity somewhere else. It's supposed to be another use of that word. Yes, that last answer was full register. E-gap, good. Okay. Opening the breaker points opens the primary circuit unless the ignition switch is closed, making this all messed up. Then it doesn't make a spark. And then the induced magnetic field collapses. Very good. 16 to 29, over halfway there. I asked this question specifically to the class. And you mostly got it right, so. Good. People are getting this one. What did I mean by external? Oh, sorry. Let's go to right there. Remember I drew my little box here? Let's erase and get myself something. This blue isn't, I picked a bad color. Here, let's do it this way. Erase all ink on slide. And then let's draw in dark red. This would be my magneto. Does that make sense? This is going to be in the cockpit. And then this is the wire, and this will be out at the cylinders. All right, back to this one here. None powers the primary, so that'd be in a battery ignition system. Only function of the battery is to run the radio to listen to your favorite hockey team. And I'm not going to say whether they won or lost because I'll get in trouble. But we all know what they did. Yeah, we don't listen to them very much. Just kind of do what you want, right? And who needs a GPS when you got your phone now? And the pilots all have got. There are a lot of the aircraft now, they're carrying basically iPads up in the cockpit for a lot of their work. Awesome. You guys are doing well on that. Right. In a museum. High altitude aircraft. What will you find on a modern high altitude aircraft if it's piston powered? I mean, most high altitude aircraft are now powered by gas turbines, but if we've got a piston powered high altitude aircraft, what is our most likely solution for turbo? Yeah, but what do we do for the magneto so it doesn't have pressurized magneto? Thank you. Turbocharger is what gets us there, but then we have this problem with flashover, and so we will put air pressure into the magneto. Right, secondary magnetic circuit. That's a fiction, doesn't exist. One per spark plug. Lost a lot of students here. One per spark plug. Remember, my secondary, my low tension magneto system. Every spark plug gets its own coil. This is why they're obsolete. Nobody wanted to pay for and carry around and troubleshoot 36 coils for a low tension system on an 18-cylinder engine when you could do it with 2 coils. How many coils are there? How many secondary coils are there on your engines in the shop? High tension mags, high tension magnetos. How many ignition coils will there be? 1, 2, 6, or 12 would be the obvious answers. Ooh. You have high tension magnetos on your engines. Each magneto has 1 coil in it. You're going to have 2 magnetos that look like this, and each magneto is going to have 1 ignition coil. So your engine will have 2 mags. It will have 2 coils, which will be inside those coils. It will have 12 wires and 12 plugs. Does that make sense, Sean? Me, Vincent, does that make sense? Think about the whole system. And you need to know this. How 1 unit, 6 wires and plugs. Yeah, each unit gets 6 wires, 6 plugs. And that would run the engine. But we put on 2 units for safety, for duplication. Okay. Okay, back to the Kahoot. Okay, so do we see what was wrong here? 1 per spark plug for a low tension system. And how many secondary coils does a high tension system need? If a low tension needs 1 per spark plug, how many does a high tension need? 2. Not 2 per spark plug. 2 total, 1 per magneto. A high tension system needs 1 per magneto. Is that what you're trying to say there, Braden and Travis? All right, 1 per magneto, 2 per engine. So keep that in mind. Yeah, 1 in each circuit and 2 for the engine. Right, carbon trails. They look like pencil lines. I think that's how FAA describes as thin pencil-like lines. Looks like somebody drew inside your distributor. All right, I've asked this 6 times. Let's see how you do now. Oops, I didn't see the answer there. How'd you guys do? I hit skip at exactly the wrong time. Did you folks do okay there? The answer is 2. All right, well, then looks like we did okay. Perfect. Mostly right. Of course, you had a 50-50 chance. You just picked randomly. E-gap. There are 2 correct answers here and 2 incorrect answers. Don't skip, please. Sorry, are we still reading? I find we have a lot of times where people have logged in and then they stop paying attention and we end up waiting a long time. See here, I got 23 answers and there's like 24 students. Somebody has stopped playing, so we just end up waiting. That's why I skip. But what I'll do is I'll wait till 23 people answer. All right, it is not the strongest magnetic field strength. It's the highest difference between those 2 curves. But it is important, and the most important thing here is, well, those 2, the red and the yellow are both good to know. So the P-lead safety wire, that's a jumper wire that we put that basically forces one magneto into the off position. It replaces the switch. In case the pilot turned the ignition on, we're going to go and force it off. So what if one magneto were disabled? And I haven't really talked about starting systems. We start our engines on the left magneto and then run them on both. Okay, so two possibilities. One, if you'd accidentally grounded out the left magneto, and the left magneto is the one that we use for starting, the engine won't start. If you grounded out the right magneto, the engine could start on the left magneto and then continue to run on the left magneto. Those are the only two options we've got. All right, for this one, you just look at the drawing. And I don't know what to say. If you do the drawing, there we go. Is this magneto in the off position or the run position? How is that a trick question? I don't understand how that's a trick question. How is the Kahoot a trick question? It's as simple as I can make it. This is in the run position, right? And the switch is open. What did the Kahoot ask? The Kahoot said, in the off position, a magneto ignition switch is closed. So how is that a trick question? I don't understand that. It's as clear as I can make the question. Not sure if anybody's typing an answer here or not. It used to tell me when people were typing. It doesn't seem to do that anymore. Like this, I honestly don't get why most of you got this wrong. This magneto, this drawing here, I've got a circuit right here. To induce a spark, what do I need to do? What induces the spark in this circuit? What triggers the spark? Opening the breaker points. When do I open the breaker points? At E gap, right. So what would happen if I did not open the breaker points? Would I get a spark? No, okay. So what if I put in a second path right here with a switch and closed it so that my current comes around here? It's got a choice. It can either go through path A or it can go through path B. And when I open my breaker points, it just goes through path B. Can you see that? How that would prevent a spark? Yeah. Okay. Well, what's this? This is path B, just drawn differently. If I close that switch, then opening my breaker points doesn't do anything, because my electricity goes in either this circle or this circle. And it looks longer to you and me, but it really isn't any longer for the electricity. It doesn't care. So the closed position basically grounds out my breaker points and renders them useless. Does that make sense? I mean, most of you folks are still getting this wrong. So I don't know what I'm missing. Closing that switch makes my breaker points useless. And if I don't have breaker points, I'm never going to get a spark. All right. Okay. Yeah, a lot of people seem to be mixed up on the operation of that switch. In a battery ignition switch system. Now, okay, here's a question. Does my teaching about the battery ignition system, because I always start with that. I always start with this one. And this one, the ignition switch works the other way around. Does this help your understanding or does this harm your understanding? I like it because to me it teaches the basic and then I go to a little bit more complicated. But maybe I'm just making it harder. Like I can never teach about this again. But battery ignition systems are all over the place. Mm. Yeah, you need to separate the idea of the two. Okay, but high tension and low tension. Here's my low tension system. How does the low tension system ignition switch work? Does this ignition switch work the same or different on a high tension and a low tension? Same as high tension, yeah. So even if you get them mixed up, there's no difference. It's only battery ignition versus magneto where it works the other way around because our power source is different. All right, let's move along. Almost done in the Kahoot. Mm-hmm. And that's the major difference between a car ignition system and an airplane ignition system. These ignition systems, these airplane ignition systems, if the battery goes dead, you continue to fly until you run out of gas. You just can't listen to the hockey game. Oh, good. You folks did really well.
I don't know. It just seems
The breaker points interrupts the primary electric circuit. What part is there to reduce arcing? The condenser, yes. And it protects arcing. It prevents arcing at the breaker points.
press the right button.
Okay, so if the magneto reaches E gap and we don't open the points, will we get a spark? No. If we open the points somewhere other than E gap, will we get a spark? A weak one, yes. Nathan's got a great answer there. Yes, we will, but it won't be very strong. How weak it is will depend on how far away from E gap we are. There's some places where we could open it and we will not get a spark. In general, if you're a little bit off, you'll get a spark, but it won't be full voltage. So the spark is triggered by the points. That's the whole point, no pun intended, of the points, is this they trigger the spark. Nice, 27 out of 29. Terminator 2 has understood this. I wonder who that is. Okay.